Hello YouTube, this is umills03. So now we've made it to lesson 45, which is the last lesson of new content in the Java curriculum. So hopefully you've had a good time learning about these new concepts or refreshing yourself on them. We've talked about a lot, printing statements. We talked about comments, multiple line comments, variables, switching the values of two variables, arithmetic expressions. And the list is, I couldn't even list off everything right now. I'm not going to waste the time with that. But what we're going to do is just take 20 minutes to talk a little bit more about exceptions. And then I have one new topic. So basically, we spent some of the first half of the first lesson, talking about printing statements. And the second half of the first lesson was about the importance of comments. Well, the last half of the last lesson is also going to be about printing statements. And we're going to learn basically how to print a formatted string. So we've learned about System.out.println and System.out.printf. We've learned about System.out.println and System.out.print, but we haven't learned about System.out.printf yet. So I wanted to show that to you. But before we start talking about all that, I wanted to go ahead and let you know that you could also have a nested exception block. So we've talked about nested for loops, nested if statements, and I just wanted to let you know that you could also have a nested exception. Okay, so what we're going to do is we're going to say method 11. And what you could do is maybe you throw the wrong type of exception, but basically this kind of architecture would be equivalent to just having two catch statements. Okay, so here's what's going to happen. So what you would do is you could say something like try, and then another try. So you're going to try out a particular try exception procedure. So it's going to be System.out.println of tree.substring of 8. And so hopefully you can see that that would throw an issue. Okay, but what's going to happen is it's going to basically say catch, and then what we could say is we could say arithmetic exception. So we could call the wrong type of exception arithmetic expression. You could call it apple. And then in that case, if there were an arithmetic expression there, you could just print the error message, right? So you could just print the get message, and we saw that in the previous one, right? But then we said every time you have a try, you need to catch as well. So now what if we make it another one that's irrelevant? So let's say array indexed out of bounds exception, because that's also not the issue there, right? So if we call that B, then we could just say, System.out.println of b.getMessage, no problem. And so now if we go ahead and try running this code, we can take a look at what's going to happen, right? So we have to have parentheses on all our method calls. And then we're going to go ahead and run method 11, which is right down here. And so you get a runtime exception because it says string index out of range. So you didn't call the right type of exception. So now what you could do is you could go ahead. What if you make this, instead of calling it an arithmetic exception, you call it an exception? So now this try block would be successful because this catch block successfully is going to call out this type of exception. It's a general exception for a general error. Okay, and you wouldn't even have to worry about this catch block down here. So now if you go ahead and run it, we can go ahead and say method 11. Okay, so now essentially you just have the error message. Why are we just printing the error message? Because we just wanted I guess what we can do, let's make this a little bit clearer. So we can say System.out.println of 10,000, right? So that way we'll know that if Apple is, the successful exception, then we should get 10,000, right? So now if we go ahead and run this code, we get the 10,000 there. But what if we make an arithmetic exception again, and we make the other one more general? So remember, this one used to be an arithmetic exception, and now we're going to make this one more general. So now what we'll do is we'll say System.out.println of 2, and then we're going to add a finally. So remember, we said that the finally always runs regardless. Okay, and so we want to demonstrate how that works. So if we go ahead and say System.out.println of 0, then hopefully what are we going to expect to print here? Because now this inner try block is going to have an issue. This one would be unsuccessful. So now we have to use this catch block. Okay, and then we're going to print the finally code as well. Okay, and if there are successful codes in the try statement, it'll do those first, right? So it would go ahead. Well, what happens is it would not run any. So do you think it would run hey if we go ahead and print this? So now what we're going to try to do, we're going to have to predict what's going to happen here, because we have a try catch block inside, right? And so we're going to try this code, and it seems like it would work, but it calls the wrong type of exception. So this inner try catch block, this entire thing fails, okay? And so what we're going to try, and there's no other code other than jumping right into this try block, and this try block was going to lead us into danger. So let's just go ahead and take a look at what would get printed now. So now you get hey and string index out of range. So what happens is this code is successful, right? But then it goes ahead and it now tries to run the rest of the outer try block, but then it can't do any of the rest of the outer try block. So now it's going to come down to the catch statement. So now we're going to get the message, and then we're going to get the 2, and then we're going to get the 0. So hopefully that's sort of clear to you. And this is sort of a confusing architecture. So in general, you would probably be hoping to just have one try, and then you can catch different types of exceptions and do different things. But yeah, just remember that you can also throw exceptions at your own whim. So we could just immediately do that if we want. We could say throw a new illegal argument exception right there if we want. We could do it right here at the beginning before you know, it even has a chance to catch anything at all. So if you say throw a new illegal argument exception of pathetic or something, right? And then that would just happen immediately. So actually, no, well, you couldn't have a try block after you throw an exception, right? That wouldn't make a lot of sense, because this is going to throw a runtime error. And so you couldn't, at that point, this would be an unreachable statement. You wouldn't basically have, there would be no effect of running any code that would try to prevent a runtime error after a runtime error has already been declared. So anyway, those are just a couple more details about that. I didn't want to dwell too long. One of the last things we can say about that before we talk about printing formatted strings is we can throw exceptions for invalid arguments in our person class. So let's say we wanted to create a person object, but we didn't want to let the programmer enter a name that was too short or an age that was too young. So what we could do is we would have to do this for each of our constructors, but what you could do is you could go ahead and say something like, if it's not the case that the length of n is at least 2, so you know, if it was like a 1 letter, they were passing in an empty string or something like that, what you could do is you could say throw new illegal argument exception of sorry, name too short. And then what that would do is it would inform the programmer that for this particular person object that they're trying to call, the name is too short, right? And what you would have to do is for the other constructors that accept a name, if that was a concern that you cared about, you'd have to probably make that a consistent exception for all the methods that throw a string. For the methods that throw an int, you could have an exception, you know, you're not going to let them be less than 10 years old, right? And so you could go ahead and do that. You could do that in separate statements, right? So you can now just have a separate exception. You could say something like if age is less than 10, then you could have a different type of illegal argument exception. So now you could say, sorry, age too young, right? So it's the same type of exception, but we could have some control over what the error message will be printed, as we were seeing at the bottom left. Okay, so we can try out this constructor, although I think we have to go ahead and still assign the stuff, assuming that there's no issues, right? So we could say this dot name equals n, and this dot age equals a, right? And so now what we would do is we would go ahead and compile it, right? And then we would have to make sure that all the other classes are going to compile. But now we're back to our person tester class, right? We spent a lot of time here, a lot of lessons thinking about the person tester. And so now if you could try to go ahead and say person P equals new person of R, right? If you enter a name that's too short for the constructor that it only accepts a string, we didn't call an exception for that one, so that wouldn't be a problem. And you have to remember that the exception is going to be thrown once you call the constructor, right? So once we make a constructor call, once we create the object, you know, that's when we run into the runtime error. We don't even have to be printing anything to the console. It can still throw an exception just by virtue of creating a variable. But this one's not going to be an issue, right? So this one, it would be okay. And then you could run the code and you wouldn't get, I mean, we could try to just, you know, print the person. We could print the string representation of the person object, right? So we know that the age would be defaulted to a default value. And so now we go ahead and run it and it says R is 53 years old. But now what if we go ahead and say new person of R and 44, right? So now the issue would be that the string is, that the name is too short, right? And then indeed we'd get a runtime error and it selects exactly where in the code the issue was, okay? And so so then if the age was wrong, then it would select this issue instead. So then if we go ahead and concatenate R with awk, we call him rock, but then 44, we're going to take 38 years off of him and make him 6 years old. So now you're going to get a different issue, and it's going to point out a different problem with the code. So it says, sorry, age too young. So you could have basically restrictions, and you could do the same thing to your setter methods. So maybe you're not going to let someone set their name to something inappropriate, right? So you could say something, you could parse through for profanity, or, you know, you could look for prohibited characters, like you don't want stars or dollar signs in someone's name, at which, you know, in which case you could either throw an exception, or if you didn't want to throw a runtime error, but you just didn't want to accept the name, you could just have a separate Boolean where it says if the Boolean contains any of this profanity, just assign the name to something default. It's up to you as the programmer whether or not you're just going to basically reassign the value of that instance variable, or whether you actually want to crash the program. So that's basically the understanding of exceptions. Now I want to talk about printing statements. So we're going to go all the way back to the Hello World class, which is the class that we created in the very first lesson of the curriculum. What we're going to do is we're going to talk about a formatted string, okay? And so the way that it works is essentially what you're going to have is you're going to say System.out.printf. And the way that it's going to work is it's going to be a string with basically some special characters embedded into it, okay? So if you say System.out.printf, and then you're going to have basically a formatted string with special characters in it, okay? And then you're basically going to have a list of arguments separated by commas that are inserted into the formatted string. So let me tell you what I mean by that. We have about 8 minutes left. So what you're going to do is you're going to say %d if you're trying to insert an integer into a formatted string. Okay, I'm going to show you what that means. And then %s if you're trying to insert a string object into a formatted string. And then you would have %f if you're trying to insert a floating point number into a formatted string. So here's how it's going to work. What you're going to do is you could say, you know, string name equals Peter, and then you could say state equals Texas, and then you could say in age equals 32, and you could say double favorite number, I don't know, is 8.3. Okay, and so now what you can do is you're going to write System.out.printf, and you're just going to have a standard string. But every time you're going to want to input a string, you're going to write %s. It's kind of like an escape sequence where if we had inside of a string, if we had \n, we were telling Java that that was going to be a special n for printing a new line, not like the actual letter n. So what you're going to do is you could say something like my name is, and then instead of concatenating another ordinary string, you can insert this string variable right into the formatted string. So here's how it works. So my name is, and then you can call for a string variable, and you're going to specify what that string variable is after you write this formatted string. So this is basically going to be the format. My name is, right? And then if you wanted to stop it there, then you could just go ahead and say name. And so what it's going to do is it's going to plug name into where you see %s. So then if we go ahead and compile this code and run it, we're going to see my name is Peter, and there's no issue with that, right? And then if you want to pass in more, so I live in, and then you can have another %s, and then you're just going to go ahead and pass in values here piecewise. So you can go ahead and put the state in at that point, okay? And so now what you're going to do is you're going to run the main method and says my name is Peter and I live in Texas. So you can see how you use %s within a formatted string to insert the corresponding string argument. And then we're going to see a %d and a %f for a corresponding integer argument or a corresponding floating point number argument. They need to be in the correct order, and they need to correspond to the correct types. So if you try saying my name is age here, it would probably, let's see what's going to happen. So now we're going to run the main method, and I guess what it did is it converted the age to a string. And so I guess that would be okay, but you have to be careful, and you have to make sure that you put the order of arguments in properly, right? So then this would be name and this would be state, and then you could say something like I am some, you know, I am and then my age, so you could put in the D now. So now you could say age, and you're just going to pass in arguments piecewise, and it's just going to correspond to each of these percent arguments. Just remember that you write %s for a string, %d for an int, and %f for a double. And so that's not going to be an issue, and we can go ahead and see that we can go ahead and compile it, right? And there's not going to be an issue. I am 32. Okay, and so what if you wanted to have like a print FLN, right? What if you wanted to print a new line at the end of the F? What you would have to do for that is you would have to go ahead and pass a %s there right at the end of the argument. And then one of the arguments, you actually could literally pass in the string literal. So you could pass in an actual \n. And then if you do that on your System.out.printf, you just end this first string argument, this formatted double quotation string argument, with a %s, and then you make sure that the last argument is the \n. One thing I will say though that you have to be careful about is it's okay to have too many arguments in here, but it's not okay to not have enough. So if you're going to call for 4 parameters to be passed in here, right? Like we have 4 variables that we're going to call from the right-hand side here, %s, %s, %d, and %s. If you have more than 4 variables separated by commas, that's okay. But it's not okay to have fewer than that, okay? So now what if you say something like pizza right here? That's just another random string that's kind of hanging out there and it doesn't really know what to do with itself, right? And then you could say this is on a new line. You could just go ahead and make sure that the string made it to a new line, because the last thing that's going to be passed in here is that escape sequence. It's going to be the \n. So now if you go ahead and run the main method, it just says this is on a new line, so that's not an issue. But the pizza is gone. But you can't have fewer arguments. So now if we go ahead and get rid of the pizza and the \n, now we're short and the program still compiles, but there's going to be an issue here. There's going to be a runtime issue, and it selects exactly the line that had the problem. In the last 3 minutes, we want to talk about formatting with extra spacing. So what you can do here is you can see that the length of the name string is 5 right now. So what happens is if you, for example, put an 8 in between the % and the s, it budgets out 8 characters of space for that particular string variable. So now you would get an extra 3 spaces hanging out in front of name. And a similar thing happens for integers and doubles. So now if you go ahead and run the main method, you're going to see a little bit of extra spacing here. And I guess there was still an issue. We need to put the \n back here. But then what happens here, so my name is, and then what it did was it budgeted out 8 characters for that string variable. My name is, and then we had a space. And then you have 3 spaces in front of your Peter, because 8 minus 5, the length of the string is 3. So it creates an extra, 3 spacing there. The same thing can happen with doubles. And so if you had an integer that was only like 3 digits long, like 326, but then you had a 6 here, then it would give you extra spacing. So with 32, if you have a 6 there, then it's going to give you 4 extra spaces in front of that 32, right? So now if we go ahead and run the main method, so now you can see extra spaces, 1, 2, right, 3, 4, 5, 6, and then you had the I am, and then you ended it with the space. And then since you have %6d, it doesn't just give you the integer, it gives you 6 characters of spacing, but that includes the length. So you would just have 4 extra spaces before the 32. And then finally, we can talk about formatting floating point numbers. So with a floating point number, it's pretty similar, but you're actually going to have 2 parameters. One is for how much spacing you want to give the floating point number, and then you're going to have a dot, and you're going to specify the amount of decimal digits after the after. So what you're going to do is you're going to say like 8.3242, and then this number is, right, and then you're going to say, basically you could say 10.1f, right, and then you're going to have a favorite number come into here, right, and so f is for floating point number. And what this is going to do is it's going to give your floating number 10 spaces of space, and it's only going to give you 1 significant digit of precision after the decimal point. So now we're going to see this number is, and hopefully we can decipher what's going on here. So this number is, and then you're going to have 10 spaces for the number. So 1, 2, 3 is the 8.3, and then we go 4, 5, 6, 7, 8, 9, 10. And so those were the 10 spaces for the number, and we had 1 digit of precision after the decimal point. And then it can just manufacture more if it needs to, right? So if you said 20.10, we don't even have 10 decimal places in the favorite number, but it would just go ahead and manufacture more zeros. So that's sort of the end of the Java curriculum. Hopefully you enjoyed learning about all these concepts, and I might make some videos that sort of go through some more review material, go through all of it again and do some more examples and see some cool things. So from UMozo3, thanks for watching, and please subscribe.